Hey everybody, Cranberry Alarm, Ri3D here. I'm Reese here, and
I'm Corey. I'm Jordan.
Today we're going to break down our robot for our 2025 game REEFSCAPE. We're going to start off by just breaking down kind of our strategy for this robot and kind of what ultimately made some of our design decisions and what led us down the road to end up with the final product you see here.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.
Build your alliance with so many other FIRST alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/first to learn more about their incredible programs and to get more information.
So one thing we noticed about this game is the prevalence of or the importance of coral. Coral has an impact on basically 2 out of the 3 bonus RPs. And from that, we knew that there's plenty of scoring locations for coral. There's a large cap in terms of points available. So we kind of decided that was going to be our big priority. We didn't know at the start if we wanted to be able to do L4. We kind of knew that L2 and L3 were going to definitely be a priority as we really wanted to be able to do those. But then kind of looking at the designs and thinking, looking at an elevator concept, we realized that with the 2-stage elevator, it's actually the dimensions kind of work out that you can reach the height of L4. So we decided that we would build a robot around this capability, and ultimately this led us to here. And then from there, we also knew that Algae was going to have a really big importance in the game. One, it allows you to score more points on the reef, so this is going to be really important for maxing out your score. And then also, it allows you to get the co-op, which is going to allow you to get more RP. So ultimately, Algae was our second priority, and coral was going to be our first priority. Along with coral, we kind of knew that picking up from the ground was going to be really difficult this game, just due to the kind of variability in this year's. Compared to last year with the note, where the note comes in any orientation, it'll be the exact same. This year, you can pick it up from the sides, or you can pick it up vertically, and then reorienting that to be able to score it, we knew would be a really big challenge to solve within 3 days. So we decided to build a robot kind of centered around the human player station, where the human player gets to decide the orientation. And from there, our robot can just kind of accept that, and then we can go to score it. And so we knew that with some of these design implications we knew that also climbing would be a really, really big challenge. Climbing from shallow and climbing from deep would be a really, really big challenge with all the packaging that's needed to go into this robot, along with the 3-day restriction. We knew that it might be out of our reach, so we decided to focus our efforts on trying to build the best possible robot that we could that does coral and algae. And even that was a huge challenge for us. But yeah, so I guess moving on from there, we can go ahead and break down, unless you guys have anything you want to add on our strategy.
The only thing I'd add is Reese mentioned earlier that we had a priority for the level 2 and level 3 coral. However, our initial strategy discussion basically said, L1 will be really easy to do. And then we went to get some prototypes running and started testing it. We actually found out they bounce out really easily. So that was an interesting kind of plot twist for our strategy. And we ended up being able to fix it with our end effector, which you'll hear about later.
Yeah, and we really kind of lucked into that solution. I think definitely teams shouldn't be overlooking L1, even though it seems like a really easy task. You may build a robot that can do L4, and you may miss out on L1. And I think it's going to be important to remember that. So yeah, we can go ahead and move into some of our mechanisms. I'll start with our drivetrain, and then we'll kind of go from there. But the drivetrain is really simple. It's AM14U4 chassis with a 10.54 reduction, running 4 Neos with our 6-inch high grips. Our chassis dimensions are 26 width by 28 length. And this is the chassis that we've been running for the past 3 years on Ri3D. We loved it. It's held up really well. It probably has the same wheels from the first day we built it. We're really happy with it, and it's just very robust. So not much really more to say about the chassis from there, so I'll go ahead and pass it off to Corey. He can talk about the elevator.
Right, so the elevator that we ended up selecting for this year was a ThriftyBot 2-stage elevator kit. there are plenty of elevator kits around. It's what we had available with a powered option. So in 3 days, it was important for us to have a power option, pre-built for us. And the ThriftyBot kit comes with mounting brackets, chain, and pulleys for powering both stages. But I'll go ahead and go into a little bit of the dimensions for this elevator. It's sitting around 6 or 7 inches off the ground, and each of the vertical segments of the stationary stage and the first stage are 36 inches tall, which puts us right at that 42-inch max height limit. We made a mishap whenever we were manufacturing. We made the vertical segments a 1/2 inch too tall, and so our overall robot is actually a 1/4 inch too tall. But whenever we're showing scoring demos for L4, you'll be able to see that we could raise our elevator a good 3 or 4 inches higher than we actually need to in order to score on L4. And so with more time, we would have moved some of these components to chop down our elevator height and get us within the height limit. That's just not something we could get around to. But I'll go ahead and go into the driving part of it. We're using 2 Neo 1.1s with 12-to-1 sim sports, and those are coupled on the back of the elevator here with a hex shaft. We found that with a lot of weight on our end effector, the end effector is 21 pounds, coupling these shafts was necessary. There's a lot of torque and force on these motor mount brackets, which we ended up modifying to sort of squish down our package into this 26-inch width robot. You'll notice that we're running SD sports with chopped Neo axles, and that's just so this Neo isn't hanging over the bumper a good inch. That was necessary to fit within the space constraints. I wanted to highlight one issue that we ran into that with more time probably could have fixed. Reese, can you try and lift up the elevator a little bit?
Yeah, it's maybe difficult with the robot on.
Yeah.
Let's go and give it a shot.
This bearing right here on the Thrifty elevator kit just is barely squeaking through and rubbing on the SimSport. So if you're going to go for a reduced package like this and really push where you're mounting these motors, make sure that you're not colliding anywhere. With more time, we could clean that up, but it's working well as is. And with powered up and down, it's not really an issue.
I think the theme of this robot is going to be with more time, we can make things better. I think there's definitely a lot that we missed the mark on this robot that we got to a good part, but I think there's a lot of things that we want to improve on this robot. Yeah, so moving on from there, I guess we'll talk about the end effector and the ramp. I guess on the first kind of design, when we were designing this, we designed the coral part of the end effector first, and then from there we kind of looked at, okay, how can we fit in an algae end effector or an algae manipulator and whatnot. But one real important part of the end effector is how it receives it or intakes it, which is coming from the ramp, which is right here. And we knew kind of from testing that this was something that would be really viable for us to do. It was, especially with picking up from the ramp. Other games like 2017, this has been done before, and teams have had pretty good success with it. So we knew that kind of this is something that we wanted to do, and kind of we did a little bit of iterating with it. You can see kind of there's some bends right here. These were kind of straight at one point, and we had to bend it to make it a little bit more room. But ultimately, this worked out really well. And to accept it, there's these 2-inch ThriftyBot squishy wheels right here, which will then spin and redirect the coral into the end effector. And from there, it just kind of moves it in. We use this laser can, also from ThriftyBot, to position the game piece correctly. And then I guess another point of that is looking down to the end effector for the algae. We're driving this with 125 to 1 max planetary, which then drives a 36 tooth pulley, which drives a 48 tooth pulley that's bolted directly to the arm right here. And this will basically actuate out to about that far, and these wheels will spin, allowing us to grab the algae off of the reef. And we found out that it works pretty well. The lining up is a little bit tight. It's pretty much similar to the coral in terms of the tolerance you have left to right, But we found out this works pretty well and has a pretty decent hold onto it. And we're only running about 20 amps current limit on it. So if we up that, we could probably have a bit of a better hold. But we're running the drive of this intake right here with a 4-1 Neo driving a 15-tooth pulley, then driving a 42-tooth pulley, which then drives this 42-tooth pulley down here. And this axle right here is actually a live axle for the pivot, but a dead axle for the intake. So if you see the axle is pivoting here, but when I rotate here, there's bearings here that allow the pulley to rotate around the axle. So that allows us to kind of sew it in a nice configuration and also kind of hold the game piece right here. And we'll kind of show some demos of that later, but yeah.
One thing.
Oh, go ahead.
Yeah, let's grab a couple questions from chat coming in. Question asking from Zinc Zoodles says, given the substation intakes were challenging last year, how was the decision made to use a ramp for the Coral intake system?
Yeah, so we knew that ground pickup was going to be really difficult. And with the kind of the flexibility that the human feeder station has and the fact that there's 2 human feeder stations and 60 game pieces behind the feeder stations, we knew that there'd be a surplus of game pieces for us to work with. And considering like with our robot right now, if we turn it around, we can basically go from the human feeder station directly to the reef without ever having to turn around. And that's a really big thing for increasing cycle time. To do something like this, if you remember our robot from last year with flip side, we grabbed from one side and flipped through. Pass-through mechanism with ground intake would have been something that was really difficult for us this year. So ultimately, we just kind of decided with our resources, this would be the best thing for us to do.
Yeah, I want to highlight, we really wanted a pass-through mechanism, and we actually prototyped some active capture mechanisms right out of the chute, but we decided for simplicity and not overcooking things to just run a simple ramp, and we found that that worked.
Mm-hmm.
I'll grab one more question. You might get a little more into this in a little bit as well, too. Or actually, we'll grab this one from Timmy. You guys mentioned some sensors in the end effector. What made you choose those sensors that you had? And any more details on those sensors there?
Yeah, so like you mentioned, we do have 2 sensors. Up front, we have Can and Color by Redux Robotics, and then the laser can from Grapple, provided by ThriftyBot. So some of it is down to sensors we had on hand, but also these sensors are both very fast and they don't require touching the game piece. So that's one thing that we've had issues and kind of varying results in the past with, things like limit switches and bumpers, where if the game piece is not exactly where you expect it to be because it came in a slightly different, or you get hit while you're intaking or something like that, you can get some mixed results. So having both of these, they have holes in the bottom that they can see through the Lexan for, so they see the game piece directly. And so why we have both of these, you might just think it's like convenience thing, but if you see our pass-through mechanism here, if we were to go raise the elevator right now, the coral would smash into our elevator, which is really not good. So we care very much that we get the coral all the way out of the elevator here, so that we know it's safe to run. That is what the laser can is doing. And then on the opposite end, for things like autonomous, we want to know that we have the coral all the way out of our robot so we can move on to the next step. And so that's what the Can and Color from Redux is doing at the front.
Awesome. So I guess from there, we've kind of given a brief overview of the whole robot. So I guess from there, let's just kind of show it working, right?
Sure.
Let's do it.
Yeah, we'll grab some questions after we do some more demos.
Okay, let's do it. So I guess we'll start off by just, we'll stay over at the feeder station for a while. Let's just do some quick cycles, just in and out, in and out, in and out, and just kind of show what the variability of this ground intake is and what our capabilities are. Oh, not ground intake. Yeah, thank you. Hopper, or feeder station intake. So we're just going to start off with some just light drops. And you can see there the laser can detected it and then just dropped it from there. So once the laser can sees it, what we do is we actually lower the speed of the intake, and that allows us to kind of serialize it the way that we would really like. There we go. Then sometimes we get a really good pass through right like that. And for the most part, this goes through every time. I think we've had a few cases where it doesn't quite go through every time, but we have pretty good success with this. All right, so let's go ahead and shift the human player station, and let's kind of show some from the side. Oh, you're good. That good? Yeah, let's do that. So you can see, even coming from the side, we're able to pick it up pretty well. And the goal of this was to be able to give the human player a minimum of 2 viable slots for dropping the coral into the robot. And we wanted to just be able to drive up, and the human player from anywhere can just eject it. So yeah, let's go ahead and try with you just kind of throwing it in from now. What's that? Yeah, that's fine. So even with the human player throwing it, we do a pretty good job. Here you go. All right, so let's go ahead and now try. Go ahead and eject. There you go. Let's go ahead and try. We back up the robot. Well, let's put a coral in the way. As many times during the game, there's probably going to be drop coral, and there's going to be coral in your way. So let's see how this works. So we do sometimes, go and hit it one more time. There you go. Sometimes the laser can bugs out and we don't quite get it through. And that's on our end, on our programming side, that we just need to refine. So even with the gap there, we do handle it pretty well. And the way we were able to handle this is that we had to drop the height of this edge pretty significantly. The hoppers, the feeder station right here is at 37.5 inches. Our hopper is sitting right around at 31 inches. So that drop right there is what really allows us to grab the game pieces from afar. All right. From there, you guys want to do some scoring? Let's do it.
Yeah, so you can see, as I was mentioning before, kind of with L1, one of the things with our design specifically, so we were talking about when we were designing our end effector, if we were going to have a pair of wheels on top and bottom versus left and right. And for a lot of cases, we kind of came to the conclusion they would be very similar. But one thing we did recognize after trying it actually was just some drills, is that if you had a difference in speed between the two, you kind of get this kick-out mechanic as the coral leaves the intake. So when we're scoring on L1 here, we run the left one, I think, like 20% slower than the right one. And what that does is you'll see it kind of kicks it out so that it's parallel with the trough as opposed to straight out. Like I mentioned before, we had tons of bounce outs. And you can kind of, I don't know if you can see on camera, but we have tons of gouges in here from just trying to like jam it in there. And so that's one of the things that we think, wheels on either side might be advantageous for keeping the coral in the trough. So you can kind of see we did bounce out a little bit there, but you can kind of see as it comes out, it does twist it. So he's showing you there more easily being able to see the twisting motion. But it is very consistent in landing there, parallel to the plane here. You want to show stacking 2 on top of each other? One thing we found is this generally works pretty well. Might as well try a third. This is basically the most you can score kind of in a row. And this is not super consistent. That one actually will score. So it's one of those things where you don't want to pile a ton up because you might be wasting time if they come out. But if your primary scoring location is L1, you can fit a lot of game pieces in there.
Yeah, and this is also with the L1 and kind of our missed shots and whatnot. That's kind of one thing with more time, we could definitely refine that. Reducing the speed of the rollers is one really big thing that could probably help a lot, and we have another time to be able to do that. So with this design, I think it would be more than capable of that. Yeah, so let's go ahead and move to L2 and show that. Nope, maybe we need a table and re-enable. We've been noticing a little bit of a bug sometimes in our code that doesn't allow our elevator to rise sometimes, so sometimes we need to recycle. There's L1, or L2, sorry. So, there you go. We'll do L3. Very nice. And L2 and L3 are pretty straightforward. Where some of the funkiness comes is when we go to do L4. We've had some mixed results with this. go ahead and hold down. Yeah, there you go. You got it. We did notice that the lineup for this is going to be a little bit difficult, so it's important to get it right away. So this is one thing that we, in our testing, we thought would work out pretty well, is basically being able to eject the main piece onto L4 with our current 12 and a half angle. We've noticed varying results. We haven't been able to get this on the robot. We think that with more time to be able to tune it, this is a real possibility that this could work out. But we're no guarantee that on this one will work. Got it. But for L2 and L3, this angle is really, really optimal for being able to score into the L2 and L3 rungs.
Can you go back and do L4 and re-explain that since you're muted?
Yeah. Sorry, Chad. I can't unmute my mic properly.
We should also mention that this is not a full field, and part of the advantage to L4 is being able to push against it, which you can't do.
Yeah. And so that's another thing that what Jordan just mentioned to me is that we can't really fully push against this. And so maybe that's something that we would be able to do and maybe get some better results. But we're going to show this one more time. So you can see here we kind of push our robot back. So maybe there's some more control that we can do here to basically keep the robot in place whenever we go to score on L4. Maybe slow down the rollers. I think there's a lot of fine tuning and levers that we can pull to get this to work out. From what we saw with our testing, we thought it would be capable. It's also important to be aligned when you go to score. Yeah, depth perception is a real thing. And that what happened there was because Corey wasn't paying attention and pressed the intake button too many times. He's a good driver, I promise. But as far as L2 and L3 go, we're really, really pleased with how this came out.
All right, let's ask a couple questions from chat in terms of this as well too. A big question that's come up quite a few times is in terms of balancing and tippiness and things like that. We did some testing, a while ago for that. What about now? How's the robot doing so far? And any counterweights or anything like that?
So we did have some counterbalance to the back, just with some zip ties and what we had laying around the shop. But we can go ahead and show that. It is very tippy. I think Corey would be more than capable of tipping this robot with one thing we really didn't have time to add like we wanted to is a drive limiter when the elevator is up. This would basically just limit the drive speed so that we can drive at a really slow speed. But that's just on driver skill right now to do that. So I guess, Corey, let's go ahead and go up to L4 position. And let's just give it a little bit of a drive and then try not to tip. But let's see kind of how tippy it is just when we do a little bit of driving. So it's going to be important to not pull away from the reef really fast and kind of move at a pretty good speed and bring the elevator down before you start moving fast. So this robot is pretty tippy up in L4, and that's where it's going to be important to stay inside the reef when you're kind of going up. There's really no reason to be extended up high when you're outside the reef zone. So that's just going to be that's going to come down to driver skill and also a little bit of programming to help out with that.
What sensors are you using on the elevators for your different stages and for your stops, that sort of thing? And that was from Jorge Enrique Sanchez.
Yeah, so the sensors that we're using currently, we are using the internal encoders on both Neos, and so that's kind of giving us general position control ability. We also, if you want to point the robot the other way, maybe go up to L2 or something, we can show there's a limit switch, an end of travel limit switch at the bottom that we're using for a safety mechanism if you want to point the drivetrain. Yeah, so you can see right here, when I press that, I don't know why I got a static shock, but anyway, so that's hooked up in a way so that when the elevator's all the way down, we don't have to worry about burning out motors or killing things. As far as the top, we don't have a limit switch on top. We would highly recommend one. But as mentioned before, we have several inches, like 3 or 4 inches, above the L4 for where our elevator will go. So we feel it's pretty safe right now. If you were going to the absolute max of your elevator, I would definitely encourage putting a sensor up there. for this one, it was kind of all right to leave out.
Question coming in from Ardna asking for alignment to the reef. Are any tips or tricks or anything like that to try to get good alignment to the reef?
One thing we don't have that I would highly encourage you to have as a former driver is some sort of camera that can just give a point of view basically right down the barrel of whatever you have aiming the coral. Depending on which driver station you're in and where you're trying to score, you get, especially with so many sides of the reef, you're going to get lots of different angles, and it's going to get hard to see things, especially, also considering that if you're not de-algifying the reef, there's also the balls in the way. So I think visibility is going to be pretty hard sometimes, and so having something like even just a basic web camera, being able to see that, I think it's going to be really helpful.
Yeah, and I guess to build off that a little bit more, this is one thing that we kind of ran out of time with, but one thing that if we were in season, this is one thing we would definitely do, which is vision on this robot. I've seen a lot of teams use multiple limelights. This is a really good year for using 2 limelights to be able to look at the April tags. And I think a lot of teams are going to be using that to really help themselves out.
What's the current weight of the robot right now?
Last time we did it, we were at, I think, was it 89?
89.
89 pounds, so not too heavy, which is surprising that the quarter of the weight is all on the end effector.
I will say
it's without battery and bumpers, right?
That's without battery and bumpers, and we that is without the ballast on the back too.
Yep.
So that is kind of the worst case scenario, which is why we felt really comfortable adding, I don't know, 10 pounds on the back ish.
Yeah.
So it's still underweight by a decent amount. So you got to add additional weight on the back to help with tippiness. But one thing I also didn't design, and I was getting flack for this earlier. One of the things that you should consider when building end effectors is sometimes you can't just remove a ton of weight, but you can kind of nickel and dime it everywhere. We kind of erred on the side of not nickeling and diming it anywhere, which is why we ended up with a 23-pound end effector. So that is something I would definitely encourage you to do, especially with more time, is to think about those small things that add up.
Yeah. We'll ask one more question before we move on. It's from Lego Master 5197. Says, looking back, would you think a steeper angle for the end effector would have been better for scoring on L4?
Yeah, potentially. I mean, this is something that, with more time we can kind of figure out. If we end up spending a bunch of time trying to tune it and we say, all right, this isn't going to work with this one, I think 100% a steeper angle would work out for going on L4.
Yeah, there's a lot of knobs we could still turn. It's one of those things where it's really hard to tune a lot of these systems in such a short time. The angle matters, how close you are to the reef matters. We did find sometimes it's better to be further back, so there might be a sweet spot there. But then also things like how fast the wheels are spinning as you eject. Maybe it's easier. Maybe it's better to launch it. Maybe it's better to just slowly press it on. It's one of those things that you're just gonna have to play around with.
Yeah.
In retrospect, going for vertical ejection wheels rather than horizontal wheels kind of kept us from doing L4 and enabled L1. So there are probably also some other designs, maybe more rollers, which can accommodate both.
Mm-hmm. Awesome. So that's about it on kind of our info. Let's go ahead and move on to Algae and kind of showing how we kind of manipulate that game piece. Let's go and eject this coral just to kind of get it out the way. Okay. Gotcha. You can't score it? Yeah, you can score it. All right, so here we have the algae in the reef in the lower position. So let's go ahead and just go and grab this right here. So you can see we actuate out, and then from there we just drive up into it. Then we grab it, and then we go ahead and move on down. And then from here we drive over to the processor, and we already have it at the correct height. And we just eject it in. So let's keep showing that. Let's go over to the higher position of the algae now. And there was some fine tuning that we did, so it looks like our height position on that was a little high. We could lower that and be a bit better. As you can see, we got this algae all over the place. Yes, and we also have both types of algae. It looks like this one is the I don't know which one it is, but it's the one with the radial lines. So even with us being slightly misaligned, we were still able to grab it pretty well. So let's go ahead and stop right there. And so I know a lot of concerns that a lot of people probably have is, okay, you're holding a game piece outside of your frame perimeter right now. So we're going to be probably pretty prone to defense. So we'll do a couple slap tests just to kind of show that. So slapping from the top and bottom seemed to get it out there pretty well. Let's go and try it one more time. Let's go and grab from the A1 position. All right, let's come down, and we'll go and slap it from the, I'll go and give it some kicks. So from the sides, we actually have a really good hold, and this with it is with 20 amp current limit on a, I believe the total reduction was 11.2 to 1. We're driving a 4 to 1 max planetary, or not max planetary, sorry, sport gearbox with the Neo onto a 15-tooth pulley to a 42-tooth to a 42-tooth. So ultimately, I think it's around 11.2. I can't remember the real number with the 20 amp current limit. So upping the current limit on this probably would give us a bit of a better hold, but for the most part, we're pretty happy with this hold right here.
You mentioned something with boat types. There are two types of algae, right? Do you want to give just a really quick explainer on that?
Yeah, of course. So I think this one, the radial lines, so we have one with kind of the linear ones. Yeah, there we go. So if we get real close into this, you can kind of see the lines on this one, they kind of move this way and then perpendicular to it. Well, these ones kind of, wait, I had that backwards. Sorry, this was the radial one, and this one's with the fan. And this kind of shows there are two different types. I don't know which one is which. I know one was the Andy Mark, and then one was the Kit Aparts one. And for the most part, they feel and act the same way. There's a few differences, like from piece to piece, in terms of them being like a little egg shape. You can see they kind of roll differently. That one's going over there. That one's going over there. They're a little egg-shaped in a few ways, but we got a few gauges from Andy Mark, and we were able to size them correctly. Their pressure feels relatively the same. The grip feels relatively the same. And for the most part in our robot, they all function the same way.
Can the robot intake from the ground?
Yes. So that's one thing with this neat design that we just kind of lucked into, and it all kind of worked out. But so this is something that normally I would suggest like a really wide intake, but this works out pretty well. So we drive around like this, and then this will actually, I think, be our first time testing this scoring method. So we get to all see this live together. And so if we are from the ground like this, I think we would probably want to, no dice. Oh. Disable. So as you can see, we definitely still have a few things to work on. But the ideal is that this would rotate out like that and just go right in. Hopefully everything is okay after that. But like I think we were just popping a little bit of the belt sprockets right there. All right. Go all good? Okay. Go to there you go. Okay, perfect. All right. So we're back to business. So yes, we can pick up from ground with a little bit more fine tuning. We could probably here. I'll go and put that in there. Go ahead. There we go. With a little bit more fine tuning, we could probably get the ground to really go in there kind of smoothly. Or even like once we grab it, we can probably rotate up a little bit and get it to go in. One thing we notice is that we score into the processor. If you're not fully aligned inside the processor, and the ball kind of hits the corners right here, like here, what it actually would do, like if we were in our stowed position, go and drive into it just a little slowly for me. In our stow position, what would happen is it would hit the corner, and then from there, it wouldn't allow us to actually eject it. So I think a really big thing with the processor is making sure that the height of the ball is correct, and don't assume that you can kind of just like drive into it and the ball correct. These balls like to really grab the corners, and this is with a wood frame, so it doesn't reflect the, I believe, polycarbonate. Yeah, let's do that. So as you can see, it doesn't go in for us. I know the Kit bot did a demonstration of this, and it kind of just like drove up on it. We have our bumpers a little bit lower, so I don't think it's happening with us. We'll see. Yeah, so there we were skipping. Our wheels were just skipping. Ultimately, we think that kind of driving around like this kind of wouldn't work out too well, and really wouldn't go in at all. Corey's giving the ball a nice massage. So yeah, that about covers kind of our algae mechanism and how we score that. Let's go and take some questions from chat.
Yeah, question from Elliot. Which of the wheels in the intake are actually being driven?
Yeah, so this is another really neat. One of my old teams from 2019, we had one of our mechanisms. We only drove the bottom wheel, and this actually worked out pretty well for us. So we went ahead and tried it again this year. Like I mentioned, this axle right here, and this robot keeps jocking us, but this axle right here is a live axle for the pivot. So as I pivot, you can see these wheels are rotating as this axle moves. So this axle is completely locked relative to these wheels. So these wheels do not move. And then these wheels are down here are the ones that rotate. And that we did that because we kind of decided that grabbing from the bottom would work out in our design. And we know that we kind of figured out that you really only need to drive one side with this game piece. And it worked out pretty well.
So we have about 5 minutes left in this, so we'll grab a couple last questions on it. Question has come up a couple times. Can this robot hold algae and coral at the same time or score that way?
Yes, it can hold them at the same time. Can it score it? It cannot score coral. When the algae is inside the robot, you can see it intersects the path of the end effector. This is a design sacrifice that we made due to the angle. And maybe with some better packaging, we could get this to work. We can hold both of them at the same time. I'm sure that maybe if we pull this, it may actually be a bit close on if we actually can hold it. We really haven't tried just because we decided with our game strategy, with how our robot is, it's maybe a sacrifice that we're willing to live with, and we could afford to not do that.
Yeah, so one of the things I want to speak to, so one of the things we kind of went back and forth on in our strategy is a de-algifier that would just launch the ball somewhere, remove it from the reef to get later or have one of your teammates pick up, versus kind of an active control where you are removing it and possessing it. So we went the remove and possess style, and the reason why I don't think it's terribly important, at least for this strategy, that you can score both independently is when you're removing an algae from the reef, you're probably just going to score it right away. What Reese is showing here is this end effector can also flip up and kind of, like I was saying, just remove the game piece without controlling it. So this is pretty easy to do. While it is on our elevator, you definitely don't need it to be. You just need to get your rollers right outside your frame perimeter. So this is something that you could mount stationary to your robot and just have a single roller bar with a couple wheels or something like that to be able to de-algify at least the lower section.
Yeah, and this would at least open up 6 ports of the L3 port. In the way the game starts, only L3 is completely blocked off in every position from algae. So if you want to be able to score L3 without having some crazy mechanism, this mechanism might work out really well to be able to extend outside your frame perimeter to do that.
So as we're concluding Robot in 3 days this year, any additional work that will be done on this robot afterwards, or is it pretty much when we're done here, that's done, it's not being touched anymore?
I think mechanically, this robot is here. Maybe we had a few issues just with tension and stuff like that. You can see this idler right here that we put in. Maybe we would change the spacing there, kind of dial that in a little bit and get that a little bit better. Mechanically, I think this is almost done. I'll hand it off to Jordan and Corey for them.
Yeah, programmatically, we have a lot of work before this bot would be competition ready. One thing that we had last year that we didn't quite get to this year was automation. A lot of these sequences of movements and like intake actions can be entirely automated with the press of a single button. And so like with our sensors and sparse driver input, you could really effectively control this style robot.
Yeah, so speaking of the automation, the one that we did get to that we felt really strongly like we basically had to get to do it safely was using the 2 laser sensors up in the intake so that we can, like I was mentioning before, get the core all the way through. So all the driver does is press an intake button, and then once the coral is dropped in, it will automatically detect kind of the leading edge of the coral coming into the end effector and then slow down and kind of index it slowly until it's positioned correctly, and then it will automatically stop. So that is the one automation we got to. But it's more things like that where it makes it simpler for the driver. They don't have to think about exactly where the game piece is or anything like that. The robot knows where the game piece is, and, it's in a safe operation mode.
I do want to mention that we can announce on stream that Kettering University is going to have their Robot in 3 Days and Kitbot competition coming back up again. That's going to be on February 1st and streamed on Fun Robotics Network as well, too. So you may see Cranberry Alarm, some other teams. Well, they're returning champions, by the way. So they won in our inaugural year doing that. So you can catch that once again on February 1st here on Fun Robotics Network at Kettering University. And if you are a team that is Robot in 3 Days or utilizing a Kitbot and want to get some more experience, it's an unofficial competition. Keep an eye out for some future announcements from Kettering University on that as well. We're going to lightning round a couple of final questions before we wrap up here from things. So if we have anything else, we will try to get them the best we can for things. So question coming in from Alex. What's the angle of the hopper and the end effector?
Yeah, so it actually is 14 degrees, but we designed it to be 12 and a half, and we're just using the churro right here, and you can see we ended up running into some alignment, some collision issues with this churro, so we had to back it up. So we just like layered up some gaff tape, used that as a buffer, and I think that ultimately all of that together is what got us to 14 degrees. But the angle of the end effector is at 12 and a half degrees.
Question from Christopher. Did you end up running one side of the coral manipulator wheels faster to rotate the coral upon ejection?
On L1, yes. L2, L3, L4, no. We were ejecting straight out on that one.
From Lego Barge 5197, is the robot able to score in the barge or the net?
We cannot score in the net. No, we score only in the processor with the Algae.
From Fabier, how will you counterbalance the CG while scoring L4 or any additional changes that you might make?
So I don't think that we have a lot more CG to play with. Whenever you have 23 pounds up that high, mounting 15 more pounds a few inches from the ground isn't going to do too much. But one thing that we didn't get to, we wanted to do was reduce our acceleration and max velocity on the drivetrain whenever we are at L4 or L3 probably. And this would really help rate limit what the driver is able to do and sort of prevent the driver from even being able to put us in a position where we can tip.
Guys, any final last things you want to wrap up with before we end?
I'll say as a quick note to all the teams going into this year, definitely looking at this robot, like this robot definitely came out a bit more complex than we wanted to. I think a big part of our mission is delivering a robot that's accessible to everyone. And comparing this robot to last year's robot, this robot definitely has a lot more going on with it. But there's different versions of this robot that is very accessible. Like you can remove the entire algae manipulator and move forward with this as a coral robot and only do L2, do all 4 levels. Maybe optimize L4 a bit more, but we hope that this is something that a lot of teams can learn from. And I guess one final thing is from me is that teams moving forward into this year, packaging is going to be probably the hardest issue that teams are going to run into. So just be mindful of all the space you're taking up and the space claim of mechanisms, and just watch out for that.
Yeah, so I guess a couple of things. One, if you're interested in the code, we have it posted. I know there's a command in chat to get that pulled up. We also have it on the chief thread. So if you're interested in looking at that, by all means, do that. If you have questions or anything, feel free to open issues on the GitHub. We'll take a look at those. Last year we had lots of feedback on and questions about that, so that's something we're totally open to. We are doing this to help you teams. So
you guys will have a tech binder release coming out soon too,
yes.
right?
Correct.
Yes.
Yeah. We'll put together a tech binder, kind of detailing more details about all the different things, including the code, the controls, everything like that.
After we get sleep.
Yeah, maybe.
One thing that I wanted to mention was we're doing this to show all of you what works, what maybe doesn't work. So please take this, tear it apart, flip it upside down. Like the ideas here, you should take as a starting point to jump off and build maybe even more nuanced mechanisms for controlling these game pieces and scoring. We had a lot of limitations where we said, oh, if we had more time to design this and really iron out details, we would do it this way, but we don't have time. And that's something that I think Ri3D can help with, is showing you guys prototypes of what works so that you don't have to spend that time churning, and you can get a more nuanced design the first time around.
Yeah, I think that's something definitely I'm looking forward to. One of the things when we went to Kettering last year, there were teams that were saying, oh, we saw your design, we had an idea like that, but we weren't sure that it was going to work. So hopefully this will be a like, oh, well, that could actually work, or give you other ideas and things like that. So that, at least personally, that's one of the things I found that has been really cool the last 2 years, is to be able to see you guys make other robots that look like ours, but are way better. So yeah, that's been a lot of fun.
Cranberry Alarm, thank you so much for everything that's gone into this. Here at Fun, we've been doing Robot in 3 Days for around a decade now and stuff, and genuinely this team gets it. And I think one of the most important things is helping the teams out there, showing things like a lot of people ask, why not Swerve? Well, everybody can build Swerve, you know, for the most. There's tons of documentation. There isn't a ton on how to do REEFSCAPE, and I think that's a great thing and a great resource that you have provided out there. Thank you to all the other Ri3D teams out there as well, too, having that same goal. But this robot is absolutely phenomenal. So much for teams to learn from this as well, too. So as Jordan mentioned, keep an eye out on the Cheap Delphi thread and on Fun Robotics Network for all the technical resources coming out for that. We're delighted to continue to support that as well, too. Big shout out and thanks to supplier sponsors, by the way, especially AndyMark and the
Big
Thrifty
time.
Bot. We also received some stuff from Redux Robotics as well, too. So thank you so much to those companies who have stepped up, who continue to believe in the mission of what this is, because it is super important. So those suppliers, we really do thank their support and their continued support for Robot in 3 Days, specifically here at Cranberry Alarm as well. This archive will be out in a little bit on Fun Robotics Network. We will also be shooting a reveal video. It's more of a produced video, so keep an eye out for that. And lots of other great content here on Fun Robotics Network, especially for those in FRC. We have FRC Open Alliance coming up a lot. So if you're not familiar, it's teams who have open build logs. We'll be bringing them on camera as well, too, during the quote-unquote build season of whatever exists for that anymore. We do also have Premiere Night coming up in late February, where you can actually submit a video of whatever your progress is. You got a full robot, submit it. You're close to it, submit that. Whatever it is, you can showcase off to the FRC community. I can't believe we're continuing to do it. It's so cool that so many more teams continue to want to be part of that as well. So we're very happy and excited to have you part of all this, and we can't be more than happy to partner with Cranberry Alarm, who has just truly been phenomenal. And this is a very small team. You know, there's only I think total maybe 7 people that have been involved in this through the whole thing, and it's incredible how well they work together. No big fights this year or anything, right? So,
Maybe.
right? So not sorry. But yeah, keep an eye out for more resources for this. And thank you once again to all of you who have tuned in. We have done many millions of views on Instagram and TikTok and YouTube Shorts and stuff like that, and hundreds of thousands of views on the content. So thank you so much for tuning in and for telling other people about this content as well. And please continue to do so. And we also appreciate our YouTube members who have stepped up monetarily to support Fun, where you can actually watch ad-free content as well. So on behalf of Fun and Cranberry Alarm, we appreciate all of you for tuning in. We wish you the best of luck here in the REEFSCAPE season, and we can't wait to see what creations you build. Thanks, everybody. Have a good one.
Build your alliance with so many other FIRST alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/first to learn more about their incredible programs and to get more information.
AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.